Hey everybody, welcome to this video. This is the video for Module 23 for Business Math and Calculators, and this deals with what I call of-is problems, as well as the portion formula. So I've got a few example problems that I will walk you through to illustrate how to solve problems that involve the words of and is. So with that, I will share my screen and we'll go ahead and get started on the sample problems. Alrighty, so we're going to look at some of-is problems. And basically, the key thing to remember when you are solving problems that involve the word of and the word is that of, especially when used by itself, means multiply, and is means equals. And so the key thing is kind of setting up the problems with the multiplication and the equals sign and getting the numbers in the right spot and then simply doing the math. So the first problem we're going to look at, again, is kind of just a generic problem to illustrate the process. So what we want to do is we want to figure out what percent of 5,000 is 1,500. So the key thing to do is when you think about these kinds of problems, they always have the same structure. You're going to be multiplying two things together to equal some sort of value. The key thing is that the times symbol is represented by the word of. The equal sign is represented by the word is. So when you compare this kind of format for the problem to the original question, what you can do is you can kind of fill in the blanks based on how they show up in the problem. So in this case, the first blank is what percent. Since I don't know what that percent is, that's going to end up being my variable. The second blank that comes between of and is, between the times and the equal sign, is the 5,000, and the answer equals the 1,500. So I can go ahead and set up a simple equation that I need to then solve. All right, so the key thing again with these problems is just getting the numbers in the right spot. And once they are in the right spot, then you kind of have an indication as to what you need to do to solve. In this particular situation, we have x times 5,000. So to get the x by itself, we need to divide both sides by 5,000. When you do that, 1,500 divided by 5,000 gets you an answer of 0.3. Now, the one thing you want to be careful with in this problem is the original question asked for what percent. Our answer is in decimal form, so we need to convert that into a percent. So if you think back to that process, we move the decimal point 2 spaces to the right, and so our answer is 30%. So 30% of 5,000 is 1,500. And there you go, there's our solution. Now I used percent in the original problem because for a lot of the problems that you're going to be doing in this class, you're going to have percents involved. And so that's why I use that. You can do these problems with, things like what fraction or what decimal of. But like I said, I'm going to focus on percents because that's the main application that you'll see a lot as we move forward. Okay, problem number 2, another of-is problem. This time though, what we've done is we've kind of switched around where the numbers are and what we're looking for. So this time the problem says 45% of 2,500 is what number? Again, same general format in terms of kind of what the blanks are and what we're going to fill in. Of means times, is means equals, and then we go ahead and we fill in the blanks with the values as appropriate. So 45% is going to go in the first blank, 2,500 in the second blank, and then the what number, that's our unknown, so that's going to be our variable, that's going to go in the third blank. Now, again, the key thing to remember in problems like this is when you are dealing with a percent, in order to actually do the math with the percent, you have to convert it to another form. So either a decimal or a fraction. Typically, it's easy just to convert a percent into a decimal. So that's what I've done here. So instead of 45%, we've got 0.45. We're going to take that times 2,500. That equals our unknown, our x. Now in this situation, the x is already by itself on the right-hand side, so we simply need to multiply our values together. So 0.45 times 2,500 is 1,125. That is our solution. That's the number we're looking for, and so we are good to go. All right, one more example with dealing with a generic kind of situation. So this time we're going to do 8% of what number is 64. So again, all we're doing is kind of moving around where the variable shows up in our problem. Same generic setup. Of means times, is means equals. So we're going to fill in the blanks. 8% will go in the first blank. What number is our unknown? So we're going to put a variable in the second blank. Is or equals 64. Again, we convert a percent into a decimal in order to actually do the math on it. So that's where the 0.08 comes from, times our x equals 64. This time we have to solve our little one-step equation. So we have to divide both sides by 0.08. And what we get when we find that solution is x equals 800. And so there's the number we were looking for. 8% of 800 is 64. So I hope those first three sample problems just kind of give you an indication of just the basic structure of an of-is problem and how to solve them. Let's move to one final example, though, that involves solving a word problem where you can use an of-is kind of structure to help you solve. So here we go. At the local community college, 32% of the students are non-traditional. There are 13,600 traditional students. How many total students attend the community college? All right, so what we want to do is we want to fill in the blank with our of-is kind of formula here. Now, the key thing in this problem is figuring out, where the numbers go and which numbers to use. Now, remember, of is the times, is the equals. Okay? Now, the key on this problem is when you think about in a context like this, the number that comes before the times, like the percent that you use or fraction or decimal, represents part of the total amount, okay? The answer that you get on the right-hand side of the equal sign is also the part of the total, okay? And so what needs to happen is when you fill in either the percentage or the part on the right, they have to be talking about the same thing, okay? So in this situation, what I'm going to do is I'm going to set up the equation where I'm going to use 68% or 0.68. The reason I've used 68% is because 68% matches up with the traditional students. It matches up with that group. 32% were non-traditional, so 68% must be traditional students. And again, the reason I picked that is because the other number that was given in the problem had to do with traditional students, the 13,600. And again, the key thing is those two parts of the of-is statement should reference the same thing, should have the same label essentially attached to them. Now I'm trying to figure out the total number of students, so that's why X goes in that total space. So again, I'm left with a one-step equation that I need to solve. I'm going to divide both sides by 0.68 to get my solution, and X equals 20,000. So when all is said and done, there are 20,000 total students at the community college. 13,600 of them are traditional students. The rest, which would be 6,400, are the non-traditional. So again, this problem kind of illustrates the importance of understanding what each number represents in the context of the problem, kind of knowing what the label is associated with that, and then using those labels to kind of help guide where the values are placed within the of-is statement that you fill in. And once you've got that set up, then you can solve the problem. And then just make sure when all said and done that you do answer the question. In this case, we wanted to find out the total number of students, so that got us the solution right away. Just be careful, though, that there are times where maybe the question ask for something a little bit different than what you solve for. And so you just need to just make sure you carefully answer the question when you're solving a word problem like this. All right, so there you go. Some quick examples of, is kind of problems. Hopefully they help to illustrate, how to solve those kinds of problems. The word problems definitely get a little tricky and can be a little bit challenging sometimes to set up. So like always, please let me know if you're having problems with these kinds of situations. I'm happy to help you out, happy to talk through how to solve the word problems in particular. So please let me know what I can do to help. Reach out at any time, and I will be there to support you in your efforts. Thanks again for taking some time to watch this video. I hope it was helpful. I will catch you in the next video.